The cosine of these angles, that is called as the cos alpha, cos beta and cos gamma, are called as the direction cosines of the line L. The direction of x-axis is 1, 0, 0, y-axis is 0, 1, 0, z-axis is 0, 0, 1 based on the mutually perpendicular planes. So whenever direction ratios are given without any angles, then using direction ratios we can find direction cosines. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So here in this session, we are going up with the new chapter, three-dimensional geometry. So in our first PUC classes, you have studied all coordinate system in accordance with three-dimensional, that is x, y and z axis respectively. And here for the first session, I am going to discuss about the direction cosines of a direction ratios of a line here. So we have learnt in the chapter vectors what are the direction cosines and direction ratios for a given point. So here we are going to study the same thing for a line. Now let's take a line here. So let me take a point P here and the vector with the origin, with respect to origin, we take it as OP. We'll consider this as a straight line. So the angles made by this line with respect to x, y, z axis is called as the direction angles and it is given by alpha, beta, gamma with respect to x, y, z axis. And cosine of all these angles. So if this is the line, alpha is the angle created by x and beta is for created y and gamma is the angle with respect to z. The cosine of these angles, that is called as the cos alpha, cos beta and cos gamma are called as the direction cosines of the line L. So here we can consider OP as the line L. So the one thing is here, we always take the direction cosines in terms of positive ratios, that is in terms of positive x, y, z axis. That is why we can take alpha, beta, gamma. So we know that we can extend negative z axis, negative y axis and negative x axis also. So this is, we can take it as x dash, y dash and z dash. So which are negative x, y, z. So if we want to find out the angle created here, then it is always exactly 180 or pi minus alpha. So we know that when we have a straight line, when a ray intersects it, one angle is alpha, then the other may be considered as pi minus alpha. Similarly, so here when we reverse the direction cosines of the line L, the angles may be taken as pi minus alpha, pi minus beta and pi minus gamma. Thus, the signs of the direction cosines can be reversed. Now, any three numbers which are proportional to the direction cosines of a line are called as direction ratios. For instance, if I take A is equal to lambda L, B is equal to lambda M and C is equal to lambda N, then where lambda belongs to R, then we can say A, B, C are the direction ratios, where lambda is any scalar quantity. That is when you divide A by L, B by M, C by N, they are all proportional to each other. That is equal to lambda. Hence we can say here A, B and C are the direction ratios of a line. Now here we have, if a line makes an angle 90 degree, 60 degree and 30 degree with the positive direction of x, y, z axis respectively, find its direction cosine. So they have given alpha, beta and gamma. We need to find out cos alpha, cos beta, cos gamma. That is the direction cosines of the given line. So we have here cos 90. Then we need to find out cos 60. Then we need to find out cos 30 degree. So cos 90 is 0. Cos 60 is 1 by 2. And cos 30 is root 3 by 2. So therefore, the direction cosines or the DCs of line are 0, 1 by 2 and root 3 by 2. So these are the direction cosines of the given line. Next, if a line makes an angle 90 degree, 135 degree and 45 degree with x, y and z axis, respectively find its direction cosines. Again here alpha, beta, gamma, that is direction angles are given. We need to find out direction cosines. So we are going to find out cos 90, cos 135 and cos 45. So cos 90 is, here it is 0. Cos 135 means it lies in the second quadrant. We can write cos 135 as cos 180 minus 45, or we can write it as minus cos 45, because cos here it lies in the second quadrant. So therefore the value is minus 1 by root 2. So this is the value, and cos 45 is again 1 by root 2. So therefore the direction cosines are 0, minus 1 by root 2 and 1 by root 2. Next, write the direction cosines of x, y, z axis. For x, y, z axis means, so they are mutually perpendicular to each other. So if you want direction cosines of x axis, so the angle created with respect to x axis with respect to x axis is 0, and for y it is 90, for z it is 90 degree. So therefore we have, for x axis the direction cosines are cos 0, cos 90 and cos 90. So therefore the direction cosines are 1, 0, 0, because the angle created by the x axis with respect to x axis is 0. So therefore cos 0 is 1, and for y it is 90 degree, cos 90 is 0. For z it is 90 degree, so therefore cos 90 is again 0. So thus the direction cosines of x axis is 1, 0, 0. And for y axis, so it is mutually perpendicular to, so if I take this as x, y and z. So y with respect to x it is 90, cos 90 is 0. Y with respect to y is coincide, that is they are collinear, or we can say it is 0 degree, so cos 0 is 1. And again with respect to z it is cos 90, so therefore 0. Next, z axis. So for x axis it is 90, cos 90 0. For y axis it is 90, so cos 90 0. Z axis with respect to z axis is 0, cos 0 is 1. Hence the direction cosines of z axis is 0, 0, 1. Thus the direction of x axis is 1, 0, 0, y axis is 0, 1, 0, z axis is 0, 0, 1, based on the mutually perpendicular planes. Next, relation between the direction cosines of a line. So this we have already studied in the vector chapter while defining what are direction cosines. If L, M, N are the direction cosines, where L is nothing but cos alpha, M is nothing but cos beta and N is nothing but cos gamma, are the direction cosines of a point, and here we consider it as a line, then L square plus M square plus N square is always equal to 1. So here the relation we can consider the line here RS, so and which is parallel to the line here OP, and this is extended here. What is the direction cosines of OP? It will be cos alpha. Since the two lines are parallel here, the angle created by them with respect to the x-axis will be same. So therefore the direction cosines of this line will be cos alpha, which is L, and cos beta M and cos gamma N, and the relationship between the direction cosines is one and the same for any line which is parallel to this line. Thus it is L square plus M square plus N square is equal to 1. Next, find the direction cosines of a line which makes equal angle with respect to the coordinate axis. So we are talking about a line which creates an equal angle for all angles. That means here alpha, beta and gamma are one and the same. We know that if alpha, beta, gamma are same, that means cos alpha, cos beta and cos gamma is also same. So thus we have L square plus M square plus N square is equal to 1. So L means cos alpha, so I can write it as cos alpha square, or here I can write it as cos square alpha plus M is nothing but cos beta. Cos beta is nothing but cos alpha. So I can write cos square alpha. N is cos gamma. Cos gamma is same as cos alpha. So here also I'll take cos square alpha is equal to 1. So I'll get 3 cos square alpha is equal to 1. Cos square alpha is equal to 1 divided by 3, or cos alpha is equal to 1 divided by root 3. So thus the direction cosines are, we can say 1 by root 3, 1 by root 3 and 1 by root 3. So since we have a square root here, we can include plus or minus both signs here. So that is, we can write plus or minus for both. So thus the direction cosines of a line which makes equal angles with all the axes is plus or minus 1 by root 3, 1 by root 3, 1 by root 3. Next, relation between direction cosines and direction ratios of a line. I already said you that if A, B, C are the direction ratios of a line and L, M, N be the direction cosines of a line, we know the relation that L square plus M square plus N square is equal to 1. Also, we know that A is equal to L lambda, B is equal to M lambda and C is equal to N lambda. So, using this relation here, if I need L, then L can be written in the form of, so whenever direction ratios are given without any angles, then using direction ratios we can find direction cosines, and that is given by A by square root of A square plus B square plus C square. So this is same as the vector component where you will take the unit vector and their direction cosines, where you take it in the form of x by root of x square plus y square plus z square, which gives you the magnitude of a vector, and here this is same as that. So A by square root of A square plus B square plus C square, M is B by A square plus B square plus C square under the square root, and N is C over square root of A square plus B square C square under the square root. The sign may alter, so it may be both positive and negative. Now, for any line, if A, B, C are the direction ratios of a line, then any constant multiplied to all the direction ratios, like it may be Ka into Kb into Kc, then that is also direction ratios of a given line. And suppose if you have two direction ratios of the same line, then obviously they are also proportional. So if you have A1, B1, C1 as the direction ratios of a line and A2, B2, C2 as the direction ratios of the same line, then A1 by A2, B1 by B2 will be equal to C1 by C2. That is, they are proportional. And next is, for any line, there are infinitely many sets of direction ratios. So, we can form many sets of direction ratios for single line. Next, if a line has direction ratios 2, minus 1, minus 2, determine its direction cosines. We know that L is plus or minus A divided by square root of A square plus B square plus C square, and M is equal to plus or minus B over square root of A square plus B square plus C square, and N is equal to plus or minus C over square root of A square plus B square plus C square. So these are the direction cosines with respect to direction ratios. Now let us calculate what is square root of A square plus B square plus C square. So this is square root of A, B, C are given. So 2 square plus minus 1 whole square plus 2 square, which is root 9, which can be taken as 3. So thus we have it as 3. Now we will write this. This is equal to plus or minus A value is 2 and this is 3. B value is, so minus 1. So it may be minus 1 over 3. And C value, it is minus 2 by 3. So we have plus or minus here. So these are the direction ratios of a given line. Next we have direction cosines of a line passing through 2 points. So we have studied the vector joining 2 points. Similarly, we are going to write the direction cosines for the points and the line segment joining the 2 points. Suppose P is a point whose coordinates are x1, y1, z1, and Q is the point whose coordinates are x2, y2, z2. That is the distance from x, y, z axis. Then the direction cosines of the line joining these 2 points is given by x2 minus x1 over PQ, where PQ is the magnitude of the line, that is the length of the line, which is given by the distance formula again here, which is x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. And similarly, the direction ratios, that is cos beta, m is given by y2 minus y1 divided by pq, and cos gamma, which is nothing but n, is given by z2 minus z1 divided by pq. Next, the direction ratios of the line segment joining the points P and Q is given by x2 minus x1, y2 minus y1 and z2 minus z1. So these are the direction ratios, and whenever these direction ratios are divided by the distance PQ, that will give you the direction ratios L, M and N. So let's see here. If a line has direction ratios minus 18, 12, minus 4, then what are its direction cosines? Again, we know the direction ratios in the form of L, M, N when the direction ratios are given. So first let us calculate what is root of a square plus b square plus c square. That is, it is given by root of minus 18 square plus 12 square plus minus 4 whole square. So which is square root of 484, which is equal to 22. Now L is actually plus or minus a divided by root of a square plus b square c square. Here a is minus 18 divided by this is 22, and m is plus or minus b divided by the square root of a square plus b square c square, which is 22, and n is plus or minus minus 4 divided by 22. So therefore we can write L is equal to plus or minus, cancel it with 2, 2 9s are 2 11s are, m is plus or minus 6 divided by 11 and n is plus or minus 2 divided by 11. So these are the direction cosines whenever its direction ratios are given. Next question. Find the direction cosines of the line passing through 2 points minus 2, 4, minus 5 and 1, 2, 3. So we know that direction cosine passing through 2 points is given by x2 minus x1 by pq, y2 minus y1 by pq, z2 minus z1 by pq, where pq is the distance or the line segment which is given by the square root of x2 minus x1 whole square, y2 minus y1 whole square, z2 minus z1 whole square, and x2 minus x1, y2 minus y1, z2 minus z1 are direction ratios of a given line. So by that, first we will take what is x2 minus x1. So x2 minus x1 is 1 minus of minus 2, which is 3. So 1 minus of minus 2 becomes 1 plus 2. So therefore it is 3. Next we will take y2 minus y1, which is 2 minus 4, whose value is minus 2. Next we have z2 minus z1. So 3 minus of minus 5, which becomes 8. Now let us calculate the distance. So if I take this point as P and this point as Q, then the distance PQ is square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So which is given by square root of x2 minus x1 is 3 square, 3 square is 9, y2 minus y1 is minus 2 whole square, which is 4, z2 minus z1 whole square, which is 8 square, which is 64. So we have 64 plus 4, 68, 68 plus 9. Now we will take up L. L is x2 minus x1 by PQ. So that is 3 by root 77. M is y2 minus y1, which is minus 2 divided by root 77. And N is 8 divided by root 77. So these are the direction cosines of the line joining the 2 points -2, 4, -5 and 1, 2, 3. Next, show that the points A 2, 3, -4, B 1, -2, 3 and C 3, 8, -11 are collinear. Now we need to show that all the 3 points A, B, C. So we know that here line has divided into 2 parts, that is AB and BC, and also we know that we can have many infinite number of direction ratios for a particular line. So if I find the direction ratios for line AB and if I find direction ratios for BC, if they are proportional, that means we are giving the direction ratios of the same line. That means same line means all the points are on the same line, which shows that they are collinear. So here we are going to find out the direction ratios of AB as well as BC. Then we show that they are in proportional, so that point A, B, C are collinear. Now we will take AB, line AB. So what are the direction ratios I can get here? x2 minus x1, comma, y2 minus y1, comma, z2 minus z1. So therefore, direction ratios of line AB. So x2 minus x1 means here I can take x2, y2, z2, x1, y1, z1. 1 minus 2 becomes -1, -2 minus 3, -5, 3 minus of -4 is +4, which is 7. Similarly, next I will take direction ratios of BC. So now this is x1, y1, z1, this is x2, y2, z2. So let us subtract it. So we have 3 minus 1, 2, comma, 8 minus of -2 we have +10, comma, -11, -3, -14. Let us take the ratios of this. We will take A1 by A2, B1 by B2, C1 by C2. That is -1 by 2. And here we have -5 by 10, which is nothing but -half. Again we have 7 by -14. So they are all equal to -1 by 2. So that is they are proportional to each other. So the direction ratios of AB as well as BC are proportional. So therefore we can clearly say A, B and C are collinear. So thus what we can conclude, if the direction ratios of the two line segment are proportional, then we can say that they are collinear. So thus we have learnt about the direction ratios as well as the direction cosines of a line in three-dimensional form. So we'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.